Hey guys, my name is Bob. Welcome to the Math Help Books channel. And today we're going to solve one of the integration problem, which is the integration of cotangent square x cosecant x dx. Alright, so this question involves the use of integration by parts as well as some very minor tricks in order to solve this question. Alright, so the first thing what I will do is that I will convert the cotangent square x into cosecant square x minus 1 because there's this trigonometry identity which says that the cosecant square x, alright, minus 1 gives you the cotangent square x. Right, so this is according to the trigo identity. Alright, so after that we have the cosecant x dx. Alright, so this is the first step. So the next step what we will do is that we will expand the whole equation out, so this will becomes integration of cosecant square x cosecant x minus dx minus integration of cosecant x dx. Right, so there are two integrations to solve. One is this integration, which is the integration of cosecant square x cosecant x dx, minus away the other integration, right, which is the integration of cosecant x dx. So the next thing that we will do is for this one, alright, what we will do is that we will do integration by parts. So for integration by parts, let's just recap this integration by parts. Alright, so integration by parts, we need to identify what is my u and my dv. dv is actually the differentiated function of v, while u itself is equals to u v minus away the integration of v and du. Right, so in this case we have identified, in this case, right, my u, okay, as my cosecant x, my dv as my cosecant square x. So my u will be cosecant x, alright, my dv is actually my cosecant square x. So if I were to find my du, so my du is a differentiated form of the cosecant x. It's just basically it's just basically negative cotangent x cosecant x. For dv itself, alright, if I were to integrate the cosecant x or cosecant square x, you actually get back the negative cotangent x. Alright, so which is in this case, alright, so for this formula itself, alright, the first part itself is just basically equivalent to, let's just write it down here, alright, let's just write this down here. So this will be equals to u dv, u will be my cosecant x, and my v will be my negative cotangent x, minus away the integration of v, which is negative cotangent x, du is my negative cotangent x cosecant x. Alright, it's a bit long, and then we will just remember this integration by parts. Alright, this for this part itself. Alright, so let me just do something and we will come back. Alright, the second part of the Math Help Books, for this question itself, is to actually solve the integration of cosecant x. So bear in mind that for the first term itself, what you do is that we solve by using the integration by parts, alright, to find out what's the answer, which is in this case, this is the answer. And then what we do next is to actually find what is the integration of cosecant x. So the integration of cosecant x, alright, dx can be solved in this manner. If you have actually watched my channel, you should know. Alright, so the first thing that I will do is to place, alright, this cosecant x, alright, we have to take cosecant x minus cotangent x over the cosecant x minus cotangent x. So it's basically just make it like a fraction itself by multiplying the numerator and the denominator by cosecant x minus cotangent x, and then expand the numerator out, and that will be the cosecant square x minus the cotangent x cosecant x over just basically the cosecant x minus cotangent x dx. Alright, yeah, after which we will just basically rearrange the formulas, and then we realize that okay, this portion, the denominator, is actually my fx. All right, so this is actually my fx, and this is actually my f prime x. So it's actually using the idea of the recognizable forms to solve, and in the end, okay, this is equivalent to ln the absolute of cosecant x minus cotangent x plus c. All right, so here is the answer to the second part of the integration. So this is the first part of the integration, which is this, while the second part of the integration is just basically ln absolute cosecant x minus cotangent x plus c. All right, in a short while we will review the whole answer. Okay, so basically, okay, we have already found out what is my first term answer and what is my second term answer. All right, so first term is basically using the idea of integration by parts, while the second term is actually using the idea of some very basic tricks. All right, so the first integration will be just cosecant x bracket minus cotangent x minus integration of cotangent x bracket cotangent x cosecant x. All right, so if you realize that I actually removed the negative sign because the negative and the negative gives a positive. All right, so the last but not least will be it's a minus ln absolute function of cosecant x minus cotangent x, all right, plus c. All right, so basically you realize that it's actually a recurrence function. So this question and this part here itself, it's the same. All right, and then what we will do is that we will bring the integration over to the left hand side. So let me just rewrite the whole equation. So therefore this is equivalent to the 2 times of the integration of cotangent square x cosecant x dx, which is equals to the negative of cotangent x cosecant x minus away the ln of absolute function, the cosecant x minus cotangent x plus c. And of course, last but not least, we will divide both sides by 2, and the final answer will be in this format. So the integration of the cotangent square x cosecant x is equals to the negative of cotangent x cosecant x minus with the ln of absolute function of the cosecant x minus cotangent x divided by 2, oops, my line is a bit off, plus c. Alright, so basically this question itself is pretty much long, but what you can do is the first term, we use integration by parts by making cosecant x as my u and my cosecant square x as my dv, solve it from there. As well as for the second term itself, what we will do is to multiply the numerator and the denominator by cosecant x minus cotangent x, that we should make it like a fraction, right? And use the recognizable forms of the f prime x over fx in order to solve this question. And yep, that's about it from me. Yeah, thank you guys for watching, and I'll see you in the next video.